Greetings, folks. Joseph Kursky here with you to talk about a important topic, spatial data science in an age of scientific disruption, a curriculum. These are remarks that I gave at a recent Cartography and Geographic Information Society / University Consortium for Geographic Information Science, or GIScience Symposium at The Ohio State University. The question was, we are in an era of disruption, not just distribution in the practice of science, but disruption in the world through processes such as climate change, migration, and geopolitical conflict at all geographic scales. These are the types of problems geographers are good at addressing. How can GI science education bring these types of problems into the classroom? And how do educators also bring forward holistically and systematically thinking about disruptions? That was the prompt to our panel, which included me and some wonderful people that I know and also that I met at the conference, Kaglar Koilu, Forrest Bolick, Amy Bernicki, me, and my colleague Kanserina Kernia. My remarks are as follows. First of all, the era of thinking your department or even your university or college will exist in 100 more years just because it has existed for the past 100 years, I believe, are over. There have been many essays, including my own recent essay about Change Brings Innovation essay, about many colleges closing at least part of their campus or programs or the whole thing. However, disruption and challenges can foster innovation. I truly believe that. What should our university and department and programs focus on in the coming years to remain viable and relevant to the rest of the campus and to greater society and to our students, and attractive to those students? Number two, what should we name our courses and programs? Sometimes I think that the names that we have are rather stale. GIS 101, Intermediate GIS, Intermediate Remote Sensing. Why not more courses called Digital Earth, Smart Planet, etc.? What should our programs focus on? How can we embrace modern geospatial information and grapple with the pressing issues local to global, including the UN Sustainable Development Goals? My recent post about sometimes change fosters innovation might be helpful here. Also, I say that we should use ethics in instruction to foster these higher, more noble goals. Location privacy, copyright, ethics, especially in our geo-AI-enabled environments. I also think we need to be focused on systems thinking. That the ecosystem is connected to the biosphere, is connected to the atmosphere, is connected to the hydrosphere, the anthroposphere, the human sphere. So the systems and spheres are connected. If we alter a variable over here, variables over here are going to be impacted. That's the modern world in which we live. It's not so clear-cut most of the time that a decision will benefit everyone and nobody will suffer. It's a fine line. Think of changes in cities where you've got a light rail going in and suddenly the prices of those apartment buildings and condos go way up and the people living there can't afford to live there anymore. So there's disruption. Sure, there's new businesses and housing units near those light rail lines, but what about the people that are disrupted? What about the people that have to move? Where are they going to move to? So there's decisions that we make on the landscape that are difficult. They're sticky. They're wicked, difficult problems. And that's the world in which we live. I believe, though, that ethics should not be relegated to week 15 of a course, but it should be threaded in. These difficult ethical issues should be threaded in throughout our courses. So systems thinking, ethics, and choosing topics of interest to students at a local level. Trash, dangerous intersections, where do you feel safe in your community, cool skateboard parks, noise, etc. Two global problems, but also focusing on local issues as well, community gardens, all kinds of historical homes. There's all kinds of things that we can foster geospatial skills, but yet embrace and engage students in local issues that they actually care about. And also themes. The themes could be climate, public safety, transportation, hydro, water quality, history, historical settlement, etc. There's all kinds of issues that we can grapple with. That's the beauty of, the wonder of geospatial technology, is that we're actually grappling with real-world issues. And we have real data to back up those issues and to grapple with those issues and also to propose solutions for those issues. So those were my remarks for that first question, for that first prompt. The second prompt is as follows. What should be included in a GI science and spatial data science curriculum in an age of disruption and scientific transformation? What concepts should we teach? What skills, what educational changes are needed to ensure that the next generation of GIS users and GI science developers are prepared to face the challenges of our changing world? First and foremost, I believe we need to foster student engagement, inquiry, and excitement. If students aren't engaged and excited about the first weeks in the first course, they're not going to pursue this in the future. Sometimes I get these cringe moments when people say, Joseph, I took a GIS course that was the most boring thing in the world. Why, I say? Well, because we spent a month on metadata and a month on map projections and a month on developing a geodatabase. Now, I'm not saying those things aren't important, but we can save at least the bulk of those things for course number 2, course number 3. Sure, there's an engaging way to teach all those things, including map projections. You know, Greenland is not bigger than Brazil. There's all kinds of tools to be able to foster that knowledge. But I think we should lead with, let's go out in the field and collect data on every tree on campus. Let's look at the ADA ramps. Let's look at the light poles. Let's look at sidewalk conditions. Let's look at items of concern right here on campus or in your neighborhood if you're taking the course online. So fostering engagement, inquiry, and excitement. We've got the Living Atlas apps, drought aware, wildfire perimeters, the Wayback imagery, so you can look at changes in your own neighborhood, changes around the world, glacial retreat, agricultural expansion, urbanization, deforestation, reforestation, and much more. So those tools are engaging. They get students thinking spatially. They get them using geospatial tools, imagery, data, and start thinking spatially and holistically. So fostering student engagement, inquiry, and excitement, I think, is our first and foremost goal. Number 2, tackling real-world issues local to global. Look at the UN SDGs, the Sustainable Development Goals. Health, environment, economics, education. All of them are spatial. They all can be grappled with using geospatial tools and spatial thinking. This tool right here, your brain. Number 3, I think we should lead with GIS tools that are on the web. Tools, data services on the web mapping applications, etc. And I think we should do this whether this first course is the students' only exposure to GIS or their first of many exposures to GIS. Business Analyst Web, AI-powered analysis tools, web mapping applications, instant apps, etc. The modern GIS approach is what my colleagues and I call that. Number 4, get out into the field. Get out into the field. Campus, community, and beyond. Collect, map, analyze, communicate the results of what you're finding out there. Soil moisture, noise, weather, historical homes, etc. Number 5, now is the perfect time to reconsider long-standing workflows that may be less in demand and relevant in the future, such as census data and statistical area joining. Now, I and probably many of you had our tried and true lesson for years where we had the students go out to census.gov and grab all of the census tracts and block groups for a certain area, and then join that data, join those polygons to census statistical data. That was very arduous, involved a lot of procedures in a GIS to do, and I would argue that there's other ways to teach joining. Joining is still an important skill, but you can do it, for example, joining your local data to the Living Atlas of the world. You can join that way in a fraction of the time. Still teaches joining and the relationships, but you're not going through in my case, I had a 40-page lab. And I love that 40-page lab. It's hard to give up those things that we spent so much time honing and perfecting over the years. But I would argue that students are probably never going to have to do that in the workplace. They're never going to have to go through those procedures. And that's hard for me to say, too, because I used to work at the Census Bureau. I love the Census Bureau. I was a geographer there for years. And I love that data. I still do love that data. And you can use that data inside a data service now inside ArcGIS Online, for example. So reconsider long-standing, long lab exercises that may be less in demand and less relevant in the future. I really encourage you to do that. Number 6, reduce long step-by-step lessons. The granularity, this is on a related note, in favor of problem-based, focused, shorter lessons. At one point in history, all students had were our labs, our professors' labs, and the labs that we as instructors created. Now they've got, if they get stuck georegistering an image or a historical map, they could go to a video. They can go to the help documentation, which is really like an ebook nowadays. It's not just documentation for software. It's really quite engaging. It's got videos. It often has graphics, clear explanations. So if they get stuck, they don't just rely on your labs anymore. So you don't need to make those labs long. And if you make them shorter, you will not be in that perpetual cycle of redoing your screenshots every semester when the software changes. I mean, ArcGIS Online changes quarterly. What if in the future it changes monthly? What if it changes weekly? Are you going to be updating your labs every week? So again, those were valuable for their time, but we don't need to do those anymore, I would argue. Shorter lessons reduce the amount of step-by-step. I found that over time, the students read my step-by-step lessons less. They go to where I'm asking them to fill out or share their map or fill out an answer to a question. They don't read those things anymore. They don't need to read those long labs anymore. So try to reduce the amount of granular labs that you have. And number 7, do all you can to foster GIS and spatial thinking beyond GIScience programs on campus. It needs to be in economics, in business, in data science, in civil engineering, in history, in mathematics, in civil engineering. Did I say civil engineering already? Anyway, the point is it's too valuable a tool and a perspective just to be in 1 or 2 departments on campus. I love the Geo, Enviro, GIScience programs on campus. I'm a geographer. I've got 3 degrees in geography. I love geography. Okay, but it's too important to just have in 1 or 2 departments. So we need to get it out there for other students to grapple with. Maybe in not the same ways as the Geo, Enviro, GIScience community grapples with, because they're going to be the experts. They're going to be the people that provide mentorship to other disciplines. If I'm teaching location analytics and business, I want my supply chain students, the target marketing students, and others to know some about this, but they don't need to know every single thing that a GIScience student does. So do all you can to foster GIS and spatial thinking beyond GIScience programs on campus. Do a little bit of coding with your students. In the WebGIS world, it's so important. Have them dip a toe into arcade expressions, 2 or 3 line expressions to enhance your filtering, enhance your labeling, enhance your symbology on that map or maps. So those are easy things to do. And then on a deeper end of the swimming pool, it's the Jupyter Notebooks. Incorporate a little bit of Jupyter Notebooks in your classes. Those are some ideas. And there's lots more we could talk about, how to integrate GIS into your drone or UAV program and much more. But I hope those comments are helpful. And again, these were made in reference to this spatial data science in an age of scientific disruption. Again, I hope those comments were helpful. I would love to hear your feedback. Thanks for watching.